Our hypothesis is that the pulse river systems that are in the northern Gulf of Mexico played a large role in the redistribution of oil and created unusual opportunities for organisms to be exposed to oil. So it really comes down to the role of rivers when you have large oil spills. If you think back when the oil spill happened, it was early, sort of in the spring, following a very wet winter, and so there was a lot of discharge of water coming out of Mobile Bay and the smaller estuaries around Mississippi Sound, and then the river itself, Mississippi River itself. When I was working at Dauphin Island at the time, the projections for oil coming on shore were these 3-day forecasts. Oil was coming in 3 days, 5 days, the oil would be here. A lot of resources went into putting boom out and protecting, especially around the islands. And the oil never really came in. I mean, it stayed offshore, and the reason why it stayed offshore was because of the surface fresh water coming out of the bay and out of the sound. We're essentially pushing that water off. And then another thing happened in Louisiana when they opened up diversions to try to keep the water off. It actually exacerbated a lot of things, both ecologically, but it also changed the circulation of the northern Gulf as well. And so we have been looking at the physics of the water at a really unprecedented scale, so very, very high resolution, and we're also incorporating some forecasting so that, you know, in 3 days, in 5 days, you can predict where water will go. We took on 3 major field campaigns, and we were operating 2 large research vessels, and then we had some smaller vessels, and we also put out some permanently located moorings that were measuring the currents and other water properties. On the ships, we were using really sophisticated lasers that would tell us about the structure of the water. When I say structure, it's the water, even right here off the shelf. It's not mixed. It's not one uniform. It's like a layered cake, and so you have to use some really high precision instruments to be able to understand that structure, because the water at the surface could be zipping along at a couple of knots, and the water below may be going this way below, and then there may be a bottom layer that's even going in a different direction. So you can't use your traditional oceanographic sampling. You've got to be a little novel. And we got one piece of equipment because we're interested in sort of the individual plankton and where they are in the water and how they layer into different, associated with these different layers, because then if the oil comes along that layer and the animals are accumulated there, it's going to create a sort of an unusual pathway for exposure. So we've got a piece of equipment that's essentially an underwater microscope. And it shoots a laser and it takes an image of all the plankton individually. And so we've got, through our 3 cruises, something like 32 terabytes of imagery data. It's really phenomenal. We also had one opportunity when they opened up the Bonnet spillway. It was an unprecedented release of water a year and a half ago. We learned a lot from that one release of water, because that sort of demonstrated that if you use these diversions, if you use freshwater pulsing out, it really changes. It doesn't just hold the oil offshore, it actually creates a new circulation. It might actually bring the oil back into shore. So we've learned a lot from both the regular cruises and some of the new opportunities to take advantage of things like the opening of the Bonnet. So we are done with our out in the field sampling. We are now in this, what we call the synthesis stage. And it's pulling all the physics and all the biology together and incorporating some of this very high resolution modeling. And we're putting it all into a single package that will then tell us where the animals are, where they're going to be, where the oil is likely to be below the surface and at the surface, and then coming up with an answer to the question, is there predictability? And if you go out into this environment and it just looks crazy mixed up, filaments and eddies, and there actually is predictability in there. There are places where we predictably see that oil at the surface will come on shore, and places where oil at the bottom will come on shore. So we're taking this last year to pull all of that information together.